10 gig network switches have been available for a very long time. The only trouble is, from a retail perspective, the options have either been limited or expensive. Now, sure, I could go on eBay and buy a used enterprise switch, but what puts me off is, well, noise levels, the power consumption that we can expect from one of these switches, and also, if I want software updates, I'd have to pay for a subscription. Now, when I was first looking for 10 gig switches, there wasn't really much to choose from. But what I've noticed recently is you can actually get 8-port switches from TP-Link, Ubiquiti, as well as MikroTik. Now, I ended up buying the actual 8-port switch from TP-Link, but what's this switch actually like to configure? What sort of features does it offer? And is it worth considering? Well, if that's something that you're interested in finding out, then stick around and watch this video, because that's what we'll be going over. Now, the switch that I've purchased is rack mountable, and you do actually get the fittings supplied with it. So I attach those to the sides of the switch, close to the front here, and then you'd attach those to the actual rack itself. Now, looking at the front of this switch, what we've got are 8 10 gig SFP plus ports. We've got one micro USB console port, we've got one RJ45 console port, and then we've got our LED indicators. Looking at the rear of this switch, what we've got is a single power supply, we've got an earthing connector, and we've also got a Kensington lock. So straight away we can see we don't get a dedicated management interface, we don't get redundant power supplies either. But for a switch at this sort of level and price range, that isn't really all that surprising. Now, what's particularly interesting about this switch is the fact that it's got console ports. Now, we've got an RJ45 console port as well as a micro USB console port. They do actually supply you with a cable for the RJ45 port. Just bear in mind that it's RJ45 to serial. Now, typically most laptops these days don't actually have a serial port. They do have USB ports, but not serial ports. So unless you've got a really old laptop lying around, you'll probably have to buy an adapter to convert USB to serial. So something like this. Now, an alternative option is to actually buy another cable, one that will convert USB to RJ45. So you could get something like this. Having said that, most of us have probably got a USB to micro USB cable lying around, in which case you could use that to plug into the actual micro USB console port. Either way, what you're getting is direct access to the switch, so you can configure it through a command line. Now, that's great if you're just starting from scratch and want to do some configuration changes there. Or if it's a case of something goes wrong and the switch is no longer responding over the network, again, you've got that direct access to be able to investigate the problem and fix it. Even if the switch is in a remote location, you can get somebody else to plug a laptop into one of these console ports, and then all you need is remote access to the laptop itself. So all in all, having these console ports is extremely useful. Now, when it comes to network connectivity for this switch, what you have to bear in mind is that these are SFP plus ports. In other words, you can't just simply plug your laptop directly into one of these switches with an RJ45 cable. You have to actually purchase SFPs to do that. So what you'll purchase is either a copper SFP or a fiber SFP, depending on which media you want to use. But when you've got servers in the same rack as the switch, you can also get a cheaper option, which are direct access cables. So those cables have actually got the SFP connected in at both ends for you. So you just connect it straight into the computer and also to the switch. So it does save you a bit of cost. The only problem is compatibility. So for example, when it comes to this particular switch, I did have some cables that I was using when I was setting up my MikroTik switch and connecting that up to my NAS, for example. But what I found is that they don't work with this TP-Link switch plus my Dell server. What I found is those actual SFPs aren't compatible with Intel. So what I've had to do is to actually purchase a specific direct access cable that will work with TP-Link as well as with Intel cards. Now, although SFP plus ports are capable of supporting fiber and copper, From what I've been reading, switches at this end of the market that are running 10 gig can run into problems when you use copper. The reason being is that copper draws a lot more power, but in doing so it generates a lot more heat, and there is the risk that the actual switch doesn't have the actual capability to get that actual extra heat out of the switch, in which case it could overheat. Now, I don't know if that's necessarily the case for this particular switch, because the way I'm steering anyway is to have direct access cables for connectivity in the rack and fiber connectivity for outside the rack. The appeal of the fiber cables is the fact that it draws less power and generates less heat, but also it has better future support for higher bandwidths. The problem with the copper cabling is at some point you do reach a limit and you do end up having to actually replace the actual cables. Fiber tends to last a bit longer. Now, that does make more sense for small businesses than home use, I must admit. The chances of me going beyond 10 gig are pretty limited, I'd say, but having said that, that appeal of keeping the electricity costs, yeah, I'm leaning towards that more than anything. But it is something to bear in mind. You do have the flexibility, but in terms of copper or fiber, it might be better to steer towards the fiber. Now, if you want to configure a switch like this directly, then you'll usually use a laptop and connect it to one of the two console ports. So you might connect one end of the cable to the RJ45 port or the micro USB port, and then the other end to a USB port on your laptop. Either way, what you end up with is the same. You've got a USB serial device. In my case, it's called COM5, and you'll want to reference that in an application like PuTTY to get your connection. Now, the default settings for PuTTY, for instance, they don't work. We do have to make some changes. So if you go to serial, tell it which COM port you want to connect to, set the baud rate to 38400 because the default setting doesn't work. Data bits, stop bits and parity you can leave at the default, but you'll want to change the flow control to none. The default setting is X on, X off. It does actually work, but the recommendations from TP-Link are to turn this off. So once you've actually got these settings in place, you can then use that to connect to the actual switch. Now, once you open the session, you need to hit return, and then if this is the first time you've logged in, you'll have to log in with the default credentials. So that is admin for the user account and admin for the password. The only thing is it then suggests that you actually change the default password, which is a good thing. When trouble is, if you say, well, no, I don't want to, it kicks you out. So really you have no choice. So we're going to change that to something different. We'll then hit return because it's just telling us, yes, the password's being changed. And then this is where things get suddenly familiar, particularly if you're used to Cisco switches, because how you configure this through the command line is basically the same. We're in what you'd see as a user prompt, basically, where you can't really do much. If you actually want to make any changes or do anything, well, surprise, surprise, you've got to elevate your privileges, and you do that with the enable command. Now, similar to the Cisco switch, you can just type in some characters, press the actual tab key, and it does auto completion. If you then hit return, puts us into enable mode. On the other hand, if I just type in enough characters for the parser to recognize, it knows what command I mean, and it just carries it out. It also has context sensitive help. So if I press the question mark, it comes up with a series of commands that I could use. Not surprisingly, if I actually want to make any changes, I've got to go into configuration mode. One thing to point out though is that, unlike say a Cisco switch, there is no terminal option, there is no file option. There's just configure and that's it. So you configure it through the terminal. And then we're into configuration mode. And then what you do after that is entirely up to you. There's a lot of things in here you can change. But if you're familiar, in any way with Cisco switches, then you'll get used to it. Well, one thing I will point out though, and it threw me, I seriously thought at one point that I was, had some mistake with the settings of the session, or maybe the actual switch itself had frozen. And that was because, well, I'm pressing the backspace and nothing happens. And yeah, it acts like the delete key, in other words. So if I use the cursor, the arrow keys, I should say, to move the cursor to say where the X is, and then press the backspace, it deletes the character below where the actual mouse cursor is. So it's, yeah, that kind of threw me. I forgot about that. I've come across those sort of problems, shall we say, before, and it suddenly just something I just remembered. It's like, ah, yeah, the backspace acts like a delete key, but it's otherwise it's similar. I mean, I can type in gobbledygook here, and oh, you know, mistyped or something, but I'm pressing the backspace and nothing's happening. The alternative is similar to Cisco's devices. You can use Control D instead of that, but the delete key itself is just garbage. It doesn't give you anything, which is a bit annoying. You can use Control U to delete an entire line. If we go into configure, well, we're already in configure mode, I must admit. We go into interface, say 10 gig, for example. I can use Control U to delete an entire line. Control W to delete words and so on. I can go forwards and backwards with the escape key, ESC-B, ESC-F, and so on. So it's extremely familiar if you're used to using Cisco switches. The other thing to point out is that when you make a change, it takes effect immediately, but your changes will not survive a reboot. You've got to save the actual configuration to flash. Not surprisingly, you do that using copy running config to startup config. So unlike ye olde switches, you don't get write mem. It's got to be the newer version, shall we say, similar to like the Nexus switches. There is none of that option for the old write to memory available. But other than that, it looks extremely familiar. That it feels the same. It's similar in the respect that if you make a configuration change, you can undo it with the no command, but there are some where you've got to put in an alternate command to undo something. I found that out through like tagging of VLANs for the .1Q trunking, for example, but I don't want to get too involved in the configuration of this because really this switch is geared more towards small business users. The expectation is all the configuration would get done through a GUI more than through like a command line. But if you're familiar with Cisco switches and you prefer to do it that way, the option's there, which actually makes it really good for automation, for example, because you'll be able to set up SSH sessions and do your configuration changes automatically, for example. But as I say, for small businesses, typically you'll use a GUI. One thing I'll point out, and the eagle-eyed amongst you might actually notice, I'm actually connecting through COM6 this time, whereas originally I was connecting or planned to connect in through COM5. What I found is that the switch has an RJ45 port and a micro USB port for console access. If you actually reboot the switch and you're connected in through the USB port, you lose your session, you get disconnected. If on the other hand you're connected into the RJ45 port, not a problem, you'll stay connected. So that's something to bear in mind. The micro USB port isn't always available. Only catch is you can't use both ports at the same time. So for example, if I've got this computer plugged into both the RJ45 port and the micro USB port, and I've got a session open on the USB port, it's a bit annoying in the sense that it basically disconnects me when I reboot the switch and I'll lose my session. I can then connect in through the RJ45 port, but once it's booting back up again and the USB port becomes available, all of a sudden you actually lose your RJ45 connection, and then you've got to connect in through the USB port. So it's that USB port is only there when the actual switch is up and running, whereas the RJ45 port, it's available as long as nobody else is using that micro USB port. So it's something to bear in mind. It's probably best to just stick to the actual RJ45 port. Don't use both at the same time. You just can't. It looks like the micro USB port seems to disable the RJ45 port if it's in use. But all in all, I'd say this is extremely useful as a feature, having this console port. I've been using Cisco switches for like a long time. I mean, I don't even count, to be honest. But it does make your life very much easier for configuration if you're familiar with Cisco switches. Now out of the box, the switch is set up to obtain an IP address through DHCP, but if it can't get access to a DHCP server, it'll revert to a built-in IP address, and that IP address is 192.168.0.1. So if you're going to connect to the switch using that built-in IP address, then chances are you're going to have to manually configure your actual computer with an IP address in that same range. So for example, this computer has got an IP of 192.168.0.100. One thing to point out is it does actually support HTTPS, which is good. So that gives you encryption for when you're connecting to the actual switch itself. If this is the first time you're going to log into the actual switch through a web browser and you haven't changed the actual password through the console, for example, then you'll log in with a username of admin and a password of admin. The first time you do this, it's going to basically force you to change that password, which is good from a security perspective. So I'm going to change this to something different. Click on apply. And that takes us to the dashboard. Now, one thing to bear in mind is that when you make changes to the switch, they don't survive a reboot unless you actually save them. But the changes do take effect immediately. So from a first perspective, what you're getting from this switch is pretty much what you'd expect from a classical Ethernet switch, all of the layer 2 plus switches and a lot more. But you also get some layer 3 features as well. One thing to point out is it's not a layer 3 switch though, so you don't get access to dynamic routing protocols, for example, but it does still have these layer 3 features. Now once you log into the switch, the first page that you see is System Summary, which comes under the System Info section, and that's part of the actual System tab. Now this is quite useful because right at the top we're getting quick feedback about the actual status of the ports. Each of them's got an LED, so you can see if the actual port is enabled or not. But if you hover over a port, you'll get a bit more feedback in terms of its status. If you click on a port, you then start to get real-time feedback on the actual utilization, which is quite handy. Then lower down, we've got information about the switch itself, including things like its firmware version. Some settings that you might be interested in knowing, for example, jumbo frames, SNTP. Each of these has then got a settings button, which is basically just a shortcut to somewhere else within the actual configuration. But it's useful to get a quick at-the-glance look at some information that's pretty important for a switch anyway. Then over on the left, we've got device description. Here you can change the actual name of the switch, its location, system contact details. We've then got system time. So you can set this up to be configured manually for time to get the time from an NTP server or to synchronize with your PC. Now this switch, it isn't connected to anything, so everything we're seeing here is just the actual default settings. So it's interesting that the system time goes all the way back to 2006. Anyway, we've then got the daylight saving time option, so you can enable that, and then we've got an option to actually turn on or turn off the actual LEDs. Now the next section that we've got is for user management. Now this is a local database that actually controls user authentication to both the command line as well as to the actual web GUI. So whereas some systems have separate logins, this is all one local user database. So it's similar to Cisco devices as well. But by default, we've just got the admin account, which you can modify. You've also got an option to add additional users, and you can also set the access level. So we've got things like power users, operators, and admins. Now the next section is system tools, and here we've got a boot config option, which basically allows you to pick which image the switch is going to boot up with, but then there's also fallback options here. We've also got another choice for the actual configuration file to load, as well as a fallback option. We can also restore the configuration from an external file here. And not surprisingly, there's an option to actually back up the actual configuration to an external file. If you want to upgrade the firmware, then you can download that from the internet and then upload it through the web browser. There's also an option here for DHCP auto install. So this is an ability to actually download a configuration file from an actual TFTP server. You can also come here to reboot the actual switch through the GUI. There's even an option here to actually set a particular time interval, a specific time that you want to actually reboot the switch. And then we've got an option for a system reset, which is to basically restore the actual switch back to its factory default settings. Now by default, the switch is set up to support both IP version 4 and IP version 6, and it's balancing its resources between the two. But if you're only using one of those protocols, what you can do is go to the STM template section here and change the actual template. So if, for example, we were to switch over to the one Enterprise v4, we'll end up with more IP access rules than the default setting. Now this switch has quite a few features that take advantage of access lists, but you can go a step further by taking advantage of time ranges. By setting these up, what you can then do is make those access lists apply only on certain days, certain times of the day, which is extremely useful. And we've also got another option where you can actually set up actual holidays as well. Now the last section that we've got under system here is for controller settings, and the idea is to be able to centrally manage all of your network devices under one central management controller. Now you do have options of cloud-based and local-based, so you can actually download some software and create your own controller. And personally, if I was going to do that, that is the method I would use. Primarily because from a security perspective, I'd say cloud-based is just a terrible idea. I know there are some vendors who only do that. My big concern is that it's a matter of when, not if, that cloud gets compromised. And when it does get compromised, that means whoever's got access to it has got complete access over your network devices via the internet. Likewise, if the vendor decides to do an upgrade, you could be forced to upgrade all of your actual kit. Or if they decide to no longer support it, well, then you've got no control over your actual management devices. If your internet connection disappears for whatever reason, and you can't get management control, again, you're stuck. So I get why vendors are pushing in this direction, money, subscriptions, etc., but no, to me it's just a no-go option. Now when it comes to the layer 2 features, the first section we land in is switching, and the first page we get is for configuring our ports. Now we also have this global option here, which although it says jumbo, this just is to do with the maximum frame size, and by default it's actually 1518 bytes, which isn't a jumbo frame. Now on a 10 gig network, you would want to take advantage of much bigger frame sizes, especially if you want to transfer much bigger files, because you get much faster throughput. We can go all the way up to 9216 bytes, but bear in mind that you want all of the devices on your network, or at least that this switch can actually service, to support the same maximum frame size. Good thing is it isn't a drop-down menu, because different vendors have different opinions as to what constitutes an actual jumbo frame. So we've got quite a bit of flexibility here as to what we can set this to. But it is a global option. You can't do this on a per port basis. Speaking of the ports, well, lower down what you can do is make changes to the individual ports. You can do one port at a time. You can do multiple ports. You can do all of the ports at the same time. We can set up descriptions for our individual ports. We can start enabling and disabling ports. We can change the speed, duplex settings, as well as the flow control. Now, because these are SFP plus ports, we've got quite a range here. Now, this is a 10 gig switch, and 10 meg to me, I'd really feel like my money got wasted if I had a 10 meg connection here. But we're dealing with a universal operating system, I'd imagine, so yeah, there's quite a lot of options basically. Now, what is useful is this, it's got support for 2.5 gig as well. Just bear in mind, if you ever do set an actual manual speed, you'll want to manually set the duplexing as well, because then auto negotiation fails and you could end up in a situation where this side is, for example, running at full duplexing, the other side is running at half duplexing, and the performance ends up being absolutely terrible. Also, you've got to make sure that both ends are capable of supporting the same speed and duplexing. I mean, typically anything above 10 meg, so like from 100 meg beyond, you may as well set the duplexing to full anyway. but it is something to bear in mind. Now, we've then got an option for port isolation, which actually gives you the option to limit which ports can actually forward traffic to other ports, which is quite useful. Then we've got loopback detection, which is where you can start getting alerts and start the auto shutdown interfaces when loops get detected within your network. We've then got an option for DDM. Now this is to do with basically monitoring and managing your actual SFPs. Now if I go over to DDM status over here, I do have two direct access cables in these two ports and there's nothing coming back on that. But port 8 does have an actual fiber SFP, so it's coming back with details about the temperature, voltage and so on. And you can start to set up thresholds for these so you can start getting alerts sent out, and you can even actually have the actual interfaces shut down if you want. And you can do it either based on an alarm setting or an actual warning setting, which is quite useful really, I must admit. Especially if you're going to be getting into the realms of copper, which I think is probably where you might more likely encounter overheating. And we can set up link aggregation groups on this switch, in other words, to bundle multiple physical links together. Now, what we've got here on this page is an option to change the actual hashing algorithm. In other words, the way that the actual switch decides how to load balance traffic over multiple links. So by default, it's set to the source MAC and the destination MAC, but you can go all the way as the source IP and the destination IP. So on an enterprise grade switch, then you can actually go further where you can actually start to balance traffic on a per application basis, whereas this, we're only getting that layer 3 load balancing, but it is still very useful. So the only thing to bear in mind is that whatever you do on the switch side, you want to make sure that the server typically matches that as well. We then got an option to set up static link aggregation groups, and you can do it a total of 8. So basically you would pick a particular link aggregation group, and then what you can do is start to select what actual ports belong in that. You'll always want an even number, not an odd number. And we've also got a support for dynamic link aggregation groups using link aggregation control protocol. And then you can start setting either the system priority, or you can make those sort of changes on a port basis if you want, rather than a global level. And you can also set the mode to active or passive, and whether you enable or disable the feature on certain ports as well. And then what we've got is the MAC address, which gives us the MAC address table of the switch. In other words, all of the actual MAC addresses that it's learned. But you can actually also filter these out if you want. You can go and search for a specific MAC address. You can start to filter it out though, and actually look at MAC addresses in a specific VLAN, learned by a certain type or learned on a certain port, for instance. You can also set up static address mappings if you like. Now, if you've got a relatively static environment and the computers don't move around, this can actually be useful, because it means if the switch always knows where a computer is, then you don't have this issue where the actual MAC address is forgotten, because it does time out after a while. And when that happens, well, then the switch has to flood the actual traffic to every port except the port it came in on. So that can be useful, as I say, especially in a static environment, because it takes a bit of a load off the other computers on the network. Because if a computer receives traffic, it's got to stop and have a look at the traffic, even if it's just to see if the traffic doesn't belong to it. And then we've got dynamic address learning. So what you can do here is change the actual aging time of those MAC address entries, for instance. We've also got an option for filtering out actual addresses. You can actually put in blocks in here if you want to. You can actually tell it to actually block traffic for certain MAC addresses. And then we've got MAC notification. So the idea behind this is, for example, we've got an option where we can actually get an alert if the MAC address table actually gets full. We can also get alerts if the actual mode of how MAC address was learned has changed. You can also get alerts if a new MAC address has been learned on a port as well, and you can set the interval as to when you actually get notified. Now, this is a managed switch, and not surprisingly, it does support VLANs. And the first page we get in this VLAN section is for setting up 802.1q VLANs. So on the VLAN config page here, all we've got by default is a system VLAN, but you can add more. And what I like here is that you can actually create the VLAN and assign it to ports all in one go. With other systems, you'd go to one page to create the VLAN, then you go to another page to assign the VLAN. So this makes it a lot easier. And you've got your options for untagged ports and tagged ports. You can also actually create multiple VLANs in one go. The only thing is you can't actually give them all the name that you want at the same time. What you then do is have to go back and modify each individual VLAN afterwards to change its name. But yes, this does make life quite a lot easier. Now, the only thing to bear in mind, just to show you an example, let's say I create a new VLAN. If I actually then tell it to delete that VLAN, there's no warning, and that can have serious consequences if you accidentally delete the wrong VLAN. Having said that, if you actually tried to delete multiple VLANs, you'd be clicking on that delete button up there. Now, when you do that, it does give you an actual warning. So just to show you again, if I do one VLAN, if I select that individual VLAN, the delete option turns up and it's giving me an actual warning prompt. But if you don't actually select a VLAN and just go for the actual recycling bin option, yeah, that there is no warning there. So yeah, that's definitely something you need to bear in mind. Now, over on the port config page is where you start to fine tune things. So over here, we're actually deciding what VLANs are allowed on ports. Now, for access ports in particular, you'll want to change the pvid to whatever VLAN that port should be in. On a trunk interface, you'd be setting this to whatever the untagged traffic's going to be. We've also got an option which is enabled by default for ingress checking. So what this does is to actually only allow tags that match VLANs that are actually allowed on that actual port. Then you can actually check what's on the actual port by clicking on details. It tells you what VLANs have been allocated to the actual port. You've also got an option to actually delete VLANs from that port afterwards if you want to. But again, bear in mind, whenever you click on the delete button here, what's going to happen is it's just going to delete it without any prompt at all. So that's a bit risky. But having said that, the good thing is you can actually delete the system VLAN, VLAN1, and that's good from an actual, best security practice, because the idea is that VLAN1 really should only be used by the system. Your computers and your servers, they all should be on some other VLAN, any other VLAN other than one. Keep this just for your actual network systems to operate and communicate on. And then finally, we've got an option to set up acceptable frame type. So by default, it's set up to admit all. The only choices really are admit all or tagged only. Now, tagged only makes sense when you've got those trunked interfaces where you are exchanging tags. You can't set up untagged only, which means you're relying on ingress checking to then check whatever list of VLANs are available on that port to actually block a computer, for example, sending traffic that's been tagged with an unacceptable tag, for example. Now, whereas 802.1q VLAN is a static way of signing traffic to a VLAN, we've also got this dynamic option called MAC VLAN. The idea behind that is that when the switch sees traffic with a certain MAC address, it can put it into a specific VLAN. Now, that does sound very useful, because if you've got a computer that's moving around on your network, for example, then it wouldn't matter which port it got plugged into, or even what switch, if you've got multiple switches for that matter. The benefit of that is that, well, traffic would always end up in the proper VLAN. The only problem is, well, you can actually spoof a MAC address, meaning somebody could actually get access to a VLAN that they shouldn't be allowed access to. Now, there is an option here for protocol VLAN, but in this day and age, it's probably not something I'd ever use, because what it's for is to actually place different types of traffic into different VLANs. So if, for example, you've got a computer and it's actually running different protocols, then you can separate that traffic out, and you can even give it different 802.1p tags if you like. But the idea is we've got some built-in templates, although if you can actually create your own. So we've got IP, for example, and IP is a big protocol suite. But typically this would be to separate out IP traffic from, say, IPX traffic. I mean, IPX traffic hasn't been around for a long, long time, but that's what the idea was behind this. And the idea is you pick your template and then use that template to decide which VLAN the actual traffic goes into. Now, VLAN VPN is more of an offering for service providers. The idea is to be able to tunnel your layer 2 traffic over a layer 2 network. Although you could actually use this if you're dealing with an actual shortage of VLANs as well. But the idea is that the traffic's got a particular VLAN to begin with, and you need to get it over your network, but you're facing overlap problems, in which case what you can do is actually wrap that traffic up in a different VLAN to get it across your network. You've just got to go through this VPN config page here to see what I mean, because if you select a port, then you've got port rules of NNI and UNI. Then you've got the VLAN mapping option where we're talking about customer VLANs and service provider VLANs. So the option is there if you need it though. Now, GVRP sounds like a useful feature because what it does is to dynamically add and remove VLAN traffic from your trunk links. So if you've got a relatively large network and you've got some edge switches, and those switches only need access to certain VLAN traffic, well, if you enable GVRP, those switches will only actually get the traffic that they actually need to see. But Cisco switches had a similar offering, and the thing is, over time, that was pretty much phased out in terms of desirability. Basically because from a security perspective, it's better to manually prune the actual VLANs on your trunk links, because then you've actually got secure control over what traffic can actually be sent to an edge switch. Now, private VLANs is always a useful feature to see on an actual switch, especially if you're going to be using management networks, where you actually want to have a centralized management solution for your actual servers, for instance, but you don't want those actual servers being able to talk directly to each other, because then it becomes a backdoor opportunity for anybody who's actually hacked into one of your servers. So like any other private VLAN offering, what you can do is to set up a primary VLAN. So that'll be whatever device that all of your computers can talk to. Then you've got a secondary VLAN, and the primary VLAN can support multiple secondary VLANs. And these can be either community VLANs, meaning that the computers in that secondary VLAN can talk to each other, which is good if you've got clustering, or they'll be isolated within that VLAN, which is good for the actual management network idea, which means that all of those management interfaces, the computers cannot talk to each other through those interfaces, but they can talk to the firewall, for example, or a management server in this upper primary VLAN. And then it's just a matter of deciding which is the actual promiscuous port, or ports, in other words, which devices can everything talk to, or you've got your secondary VLAN offerings for host ports themselves down here. So it's pretty easy to set up, and as I say, for something like a management network, it's extremely useful. Now, to be honest, this is a 10 gig switch, so I'm not going to be running management connectivity through 10 gig interfaces, for instance. But this is a kind of a universal operating system, so it's either way, it's still good to see a feature like this. And the switch does offer layer 2 multicast features, and we start off with IGMP snooping. So what this is for the switch to actually learn which computers are subscribing to which multicast group. So that way, instead of having your multicast traffic flooded out of all ports, it only gets sent to the proper ones. So we've got our global options here. Then we've got our individual port settings. Now, although we've got that IGMP option to dynamically learn about information, we can also set up actual static settings if we want to. And then we've also got an option for actual authentication, but this requires an actual radius server, for example, but it would allow you to set up accounting as well as actual IGMP authentication. Now, another option we get is MLD snooping. Now, what this is basically the IPv6 equivalent to IGMP snooping. So again, we've got our global settings here. We've then got our port settings, and then we've got our static group settings. The differences are, I've noticed, that we don't get that authentication option. Now, MVR, or multicast VLAN registration, is a rather interesting and efficient way of dealing with situations where you've got multiple computers, all in different VLANs, wanting to access the same multicast stream. Because what will happen is the switch is having to send the same traffic to all those different VLANs. But with this, what you can do is you can actually set up an actual VLAN that the computers can register to specifically to get access to that multicast traffic. And that way it actually keeps some of the load off the actual switch. So we've got our global settings here, then you've got some group settings, then we've also got our actual individual port settings to configure. Now, if you want to restrict which computers can get access to which multicast groups, then what we've got is an option for multicast filtering that lets you do that. And we've got options for both IPv4 as well as IPv6. And the last thing that we've got in this multicast section is multicast info. And what this gives you is access to multicast table information, as well as some statistics about the traffic, and that's for both IPv4 as well as IPv6. Now, when it comes to classical Ethernet switches, spanning tree is absolutely essential, although oddly enough, by default, it's actually disabled. Now, the switch does actually support different types. You can have the original spanning tree, rapid spanning tree, as well as multiple spanning tree. And then we've got our global parameters we can set here. You can also have a look at the actual summary information. So we've got information up at the top for STP summary, but then we've also got the individual instances that we can actually check out if you're using MSTP as well. We've then got settings that we can configure on a port level for spanning tree, but we've also got settings for MSTP itself. So our region config settings, instance configs we can set up, and then we can set those instances up for specific ports. And then finally, we've got STP security that we can enable at port level. So we've got loop protect, root protect, TC guard, BPDU protect, BPDU filter, and BPDU forward. Although some of these aren't specifically just related to actual security in the sense of a third party causing problems on your network. They can also be beneficial if, for instance, somebody introduces problems on the network by looping connectivity through an IP phone, for instance. Now, the switch does support LLDP, which is an open standards way of exchanging information between two devices, which is extremely useful for troubleshooting and auditing networks because it allows you to know what's connected where. So, for example, if you run this on all of your actual switches, then you'll be able to work out where the actual switches are connected to each other. You can also get information about servers if they're running that information as well, but you do have to be very careful when it comes to actually allowing LLDP on ports because, well, somebody could potentially come along, plug a computer into a port, and then find out information about the switch. The problem then is, if they get enough information about that switch that identifies a vulnerability they're aware of, they could use that against you and compromise the actual switch. So typically I would leave it on permanently on switch-to-switch links, but that's about it. So when it comes to the configuration, we've got our global config options and our port configuration options, and then we can find out information after that. Having said that, we've also got an option for LLDP Med, which is an extension of LLDP, which actually allows you to send information to IP phones, for example, or any other media device to actually give them information that they can use to configure themselves. Now, these last two layer 2 features that we've got are more really for service providers, I'd say. So we've got L2PT, which as it says is the layer 2 protocol tunneling. And that is, not surprisingly, for tunneling layer 2 traffic over a network. And then we've got PPPoE, which is basically used to actually authenticate a connection using PPP over Ethernet. So usually your internet router will actually be using this to connect to your service provider to give you access to the internet. Although you can actually get those details to set up a firewall instead, for example. Now, the switch is marketed as being a layer 2 plus switch, which basically means that it's got some layer 3 features, but not all of the ones that you'd find on a layer 3 switch. So on the L3 features tab here, the first thing that immediately jumps out is that there's no support for any dynamic routing protocols like OSPF, for example. There's also no support for layer 3 multicast features like protocol independent multicast. But what we do have is a routing table, or specifically we've got one for IP version 4 as well as IP version 6. So you can come to here to actually see what actual routes the switch does know about. The next section is for ARP, which is specific to IPv4. And what we can do here is to actually check the ARP table for the switch itself. So that's the MAC address to IP bindings that it knows about. We can actually configure static ARP entries on the switch if we want, up to 128. You can also configure gratuitous ARP, and by default this is set up for when an interface first comes up. Now, the switch does support multiple interfaces, as we'll find out. At the moment there is only one, but it does make sense, especially if this is going to be a default gateway, for that information to be advertised out when the interface does come up. But there are other options that you can set up as well. We've then got options for proxy ARP as well as local proxy ARP that we can configure. Although I must admit that these days I only tend to configure something like this on an actual firewall, but the option is there on this switch to actually configure it if you want to. And then we've got the interface section, although I noticed they've snuck in the settings for IPv4 and IPv6 routing here. So by default, we're only supporting IPv4, but this is mostly about setting up software interfaces, and it will support up to 16. By default, we've only got one, which is in VLAN 1, and that's set up to obtain an IP address through DHCP, but it also falls back to 192.168.0.1, which is what I'm connecting to. And you can set up quite a few different types of layer 3 interfaces on this switch. So if I click on add, you'll see we can set up ones for VLANs, which makes sense if you want the switch to be the default gateway in a VLAN, for example. We've also got loopback interfaces, routed ports, which is basically layer 3 ports. And then we've also got port channels as well, so you can actually set up layer 3 port channels on this switch, which is quite useful. Now, as I mentioned earlier, this switch does not support any dynamic routing protocols, so our only option is to set up static routes. And we've got choices for IPv4 as well as IPv6, but there is a combined limit between these two of 48. That's the maximum number of static routes that you can create on the switch. Now, this switch can be set up to act as a DHCP server, but also as a DHCP relay agent. Now, the DHCP server option makes more sense in small networks where you don't want to be buying a dedicated DHCP server for each site, in which case you can set this up to be the DHCP server. It'll hand out the IP addresses to the computers, and you can also set up manual binding so you can actually reserve IP addresses. In a bit of a bigger network, you can actually use the DHCP relay agent option. So the switch would act as the default gateway for the VLAN, and it would just forward those DHCP requests to a dedicated DHCP server. The only thing I would say though is that these days typically an actual firewall is usually used as the default gateway, but the options are still there if you want to use them. Now, the switch does support quality of service, and here on this QoS tab, the first section we get is for class of service, so that's for our layer 2 markings mainly. And we start with port priority, which is where we actually set the actual priority of traffic as it's coming into that port, and you can do this on a per port basis. But you've also got options for the actual mode of trust. So for example, you can set it to be untrusted, which typically you would do for an actual PC because you don't want the user deciding what priority their traffic gets. You've also got options to trust any 802.1p marking that you see, but you can also set it to trust actual DSCP markings as well. And on this 802.1p priority page, we actually get to decide the queuing for our traffic. Now, when a port gets congested, you'll typically want to start to queue that traffic up. And as far as class of service or COS goes, we've got a range of markings of 0 to 7. And what's interesting about this switch is that, well, aside from that oddball where we're going from 0 going into Q1 and 1 going into Q0, we've actually got 8 queues that we can use, meaning we could actually put all of this traffic into its own individual queue. The only catch is typically further upstream, you've probably got limited queues, especially when you're connecting to an actual WAN provider, for example. In which case, we do have this remap option if you want to use that, where you can actually remark the traffic from one priority to another, and then you can actually align the actual markings that you've got to match whatever it is that the actual WAN provider is expecting. Now, when it comes to quality of service, the markings can be done at layer 2 as well as at layer 3. So when it's layer 2, we're using the 802.1p markings, and when it's layer 3, we're using the DSCP markings. Now, when you've got traffic that's coming in through a layer 3 network, there won't be any layer 2 markings, in which case that's what this DSCP priority page is for. It's to actually align those DSCP markings to the actual layer 2 markings that you want to see, for example, although there is also the option to actually remap those DSCP markings if you want. For most people, you probably leave this as is. So for example, we've got 0 here, getting mapped to 0 for our class of service marking. And as you can see, that's to be expected. It's our best effort traffic. If you go further down, we'll then see 46 over here being mapped to 5. Well, that's to be expected. That's expedited forwarding, which you might be familiar with as being voice over IP traffic. So you've got quite a bit of flexibility here. You've got all of the DSCP markings that you can actually map to specific class of service markings and remap them all to different DSCP markings as well, depending on your own network. Now, the last thing when it comes to this class of service section is to change the scheduling settings, but there isn't really that much you can do. In fact, there's very little you can do. So by default, this is set up with a scheduling type of weighted, and the queue weight is set to 1. What that basically means is all of these queues will actually get serviced equally because they've all got the same weight. Now, even though it actually gives you a bit more information in the help section up here, you cannot actually change the weight. You're stuck with it. So yeah, not a great deal you can do in terms of that, but all you can do is to change the scheduling type. So rather than weighted, you could go for strict. Now, the difference between weighted and strict is that when you've got a strict scheduler, a queue will be serviced at the top of the list, then the next queue, then the next queue. The problem is, if any more traffic appears in that queue at the top, well, then that has to get serviced, and then it goes back through the whole process again. So you run the risk of queues lower down actually getting starved. So that's something you need to bear in mind if you ever change that. Now, the only other thing we've got here is the management type, and that's just set to tail drop. So the idea is if a queue gets full, any more traffic that tries to join the queue will just simply be dropped. Now, the next section in quality of service is for bandwidth control, and we'll start with rate limiting. So what this allows you to do is to actually slow the ports down. Now, I've got 10 gig ports on this switch, and yeah, the rate is basically 0 to 10 million kilobits per second, which is, this sounds a lot, it sounds as a big number, but even these days 10 gig is actually quite small, to be honest. But the key point is I can pick out ports, individual ones, multiple ones, and so on, and I can change the ingress rate, so I can actually slow traffic down, or at least the amount of traffic I'm willing to accept on that port. Likewise, I can actually slow the actual amount of traffic going out of a port. Now, when it comes to setting up things like rate limiting on interfaces, typically this is something that would get done by an actual service provider. The idea is they sell you a certain amount of bandwidth, and that's it. Any excess traffic you try to send will just get dropped. It's simple as that. So usually when it comes to your own internal network, you tend to smooth this sort of traffic out. That way the provider would police it if you go above a certain limit, but you'll actually slow the traffic down yourself by queuing it. Typically you do that on a router anyway, but if you do want to set up this type of rate limiting, the option is there for you. Now, one other offering that we get when it comes to bandwidth control is storm control. The only thing you have to bear in mind is you can configure rate limiting on a port or storm control, but not both. Now, when it comes to storm control, the idea is you want to be able to deal with maybe a misbehaving network card, for example. Maybe there's a problem with the actual drivers, or when there's an actual denial of service attack going on. And the idea with this is to actually set limits on the different types of traffic on a port. So if I pick a port out, I can start to set up thresholds for broadcast, multicast, and unknown unicast frames. These two in particular can have devastating consequences on your network. I mean, you can have very, very large amounts of multicast traffic, for example, just in a single stream. You can have a lot of problems caused by the broadcast traffic because every computer has to answer it. So either way, you want to be able to take action by setting some sort of threshold for these. Now, if the actual amount of traffic coming in on the port goes above those thresholds, well, by default, it's set up to just drop excess traffic. But for these two here, you've also got the option to change it to shutdown, so it actually shuts the port down. The assumption is someone's deliberately trying to cause problems. Now, what you actually set the values to, though, really depends on your own network. Back in the days when this first came out, and long before 10 gig was available, Cisco's guidelines for their network switches was set at 10% and then try to fine tune it. In other words, you want to set this to some sort of value that's just above what is to be expected. That way, if there's a bit of a spike, it shouldn't cause a problem. On the other hand, if you're setting it too high, you'll have to start to lower it and keep lowering it until you get to that sweet spot. On the other hand, if you're starting to see traffic actually getting dropped when it shouldn't be and it's causing problems, then you do increase it. But as I say, what you set these to really depends on your own network. Now, at an enterprise level, you would typically configure individual voice VLANs on the switches for the different departments. But what this switch offers is a voice VLAN feature, which basically detects voice traffic as it comes into a port, and it allows you to place it into one VLAN. In other words, all of your voice traffic ends up in the same VLAN. So here on the global config page, we get to set what that VLAN is going to be. We can also set its priority for the traffic when it comes to the QoS settings. Then we've got a choice on a per port basis to enable or disable the feature. But it's here on the OUI config page where we actually set up the actual detection for voice traffic. So these are all the ones that we get by default. All of these are different vendors that allows the switch to recognize that type of vendor's voice traffic. And the good thing is, if the actual voice traffic that you've got doesn't show up on this list, what you can do is you can actually add that in as an additional entry. Now, if you've got a phone plugged into a switch port and a PC plugged into the back of the phone, the trouble is you've now got data traffic and voice traffic on the same port. And when it comes to QoS, you particularly want to identify which is the actual voice traffic. And that's where this auto VoIP offering comes into play. Now, what you can do on a per port basis is set up the detection method, and it really depends on how that device is sending its voice traffic. So for example, if we go to the drop down menu for the interface mode, maybe the actual phone is sending the traffic in a specific VLAN, or maybe it's just sending it as untagged. Alternatively, maybe it's actually sending it with a specific 802.1p priority marking. Either way, there's quite a bit of flexibility in actually detecting that actual voice traffic that's coming through the port. Now, if you don't trust the phone, you've got options to override the actual QoS values, and you can also actually set the DSCP value as well. Now, this switch has quite a lot of security features, and here on the security tab, the first section that we land on is access security, which is about access to the actual switch itself. So we start with access control, which is about controlling access to the actual switch. By default, it's disabled, but what you can do is you can actually set this up to restrict access from computers based on an IP address, for example, based on a MAC, or to only allow access to certain ports. Now, although I've actually connected into the switch using HTTPS, it does actually support HTTP by default. But from a security perspective, that's not such a good idea because it's clear text, so it'll be best to actually disable that. When it comes to HTTPS, you get quite a lot of flexibility to lock this down. So for instance, you'd probably want to restrict the actual protocol version to TLS version 1.2. You could change the port if you want to. I would also suggest actually reducing the actual ciphers that are allowed. Go for one of the latter two because they are SHA-2, the rest are being deprecated. We've also got a choice to actually set up a session timeout. By default, it's 10 minutes. And I can tell you now that is extremely annoying when you're making videos because, well, I keep getting kicked out every now and again. And I've got to keep logging back in again. But it's a good security feature because you don't want to leave a session open for too long anyway. You can also limit the number of actual users and even specific types of users that can get access at any one time. And by default, as you'd expect, the actual switch is supplied with a self-signed certificate, but you could also upload your own actual certificate, but you'd also have to provide the actual private key for it as well. Now, when I first got this switch and saw that you can get access to it through the console and you could start configuring it just like you would with a Cisco switch, I thought, oh great, that's going to make my life easier. Came to this SSH config page and yeah, it looks as though you can start to lock it down and make it more secure. And then you notice, yeah, not that secure actually. So I'm actually glad it's disabled by default. Now you can actually try to improve it by switching it over to only accept version 2 as the protocol. You can set up session timeouts, the maximum connections, you can change the port, for example. Yeah, we can change the actual encryption algorithms, the data integrity algorithms, but this is where like the alarm bells started going off. MD5 or SHA-1. It's just not happening. These have been deprecated. Even like a Linux operating system, if you try to connect to this switch using SHA-1, which is the strongest it's got, it's not going to happen. You've actually got to reconfigure it. For that very reason, they've deprecated even SHA-1. I'm just actually really surprised that they're not offering an up-to-date algorithm to connect in through SSH, because SSH is so popular, that everybody wants to try and hack that. And if you're using deprecated algorithms, well, even on an internal network, it's not such a good idea. So it's a case of, I think it's not going to happen basic as far as I'm concerned. I did have a look at the latest firmware version. There is only one, incidentally. This switch came with a firmware version out of the box. There's only been one update released since, and I didn't see any mention of a better algorithm than SHA-1. So that's extremely disappointing, I must admit. I mean, I do like you can upload public keys, which is good, but no, that is just a big no-no for me. So it's disabled by default. As far as I'm concerned, it's staying disabled. Now, if you've ever configured a Cisco switch, you're going to get that deja vu feeling when you notice that we've got a telnet option and that by default it's actually enabled. So from a security perspective, that's a big no-no because it's clear text, so that would have to get disabled. Then the final thing that we've got under access security is to control the actual baud rate of the console ports. Now, by default, it's set to 38400, so you can lower that. You can actually increase that if you want, but that's the only setting you can change. Now, it is good to see that the switch supports AAA. So by default, we've just got a local user database account to log into the switch, for example. Here on this global config page, we've got an option to actually set up a password for the enable command. By default, there isn't one, so once you've logged in as admin, you can just enable elevated privileges straight away without having to enter an additional password. But you can add additional security in here on this page to actually apply a password, so that when somebody wants to use that enable command, usually they would be asked for a different password to what the admin account is, for example. And then lower down, we've got options to set up different login methods and enable methods for the console, for the telnet, for SSH, as well as HTTP. But you've obviously got to set up AAA to be able to do that in the first place. So we've got an option to set up TACAX servers as well as Radius servers. One thing to bear in mind is that when you do add these servers, these shared keys that you use are visible. It doesn't mask them out while you're typing them in. Likewise, once you've actually created them, that information is visible. So you do have to bear that in mind if you're ever in an environment where somebody could be looking over your shoulder, which I'm a bit surprised. I mean, it's not really good to have that. I mean, it would be better if that had been masked out, but it is what it is. Then here in the server group config page, we've got a built-in Radius group and a built-in TACAX group. So by default, anything you enter in these will be part of these groups, but you can edit these groups and you can deselect certain servers, for example, as you add them. And you can also set up additional groups. We've got an option for the actual .1x authentication as well as .1x accounting, and do have support for .1x lower down. By default, it's using the built-in Radius group, so it does use Radius for the authentication and accounting, but if you create additional groups, you could always change that to a different group here, for example. So you could have, say, one Radius group to do authentication of your network devices, and then a separate Radius group for 802.1x authentication and accounting, for instance. We've then got our method config page, so we've got default setups here, one for the login method and one for the enable method, but you can either edit these and start putting in kind of a tier, if you will. So you could say, I want the authentication done by a Radius server. If the Radius server isn't available, then it'll fall back to the local user account, for example. But you can also add in additional methods if you want. So you can have different ones here. As I say, you've got a default one which applies to everything, but you can change that if you want. And you can also go back to the global config page and start altering these. So once you've created these alternate methods, you can pick different ones, for example. But it gives you quite a bit of flexibility, as you would expect from AAA. So like I say, it is good to see that there. Now, it is good to see a feature like 802.1x security in here. Although I must admit, this is more for access switches than this 10 gig switch that I've got. With this switch, I'm more likely to just plug in actual servers rather than actual user computers. But it is a very useful feature to have, because what you can actually do is restrict the actual computers that can get access to the network. So the idea is that if you want to get access to the network, you can't just plug any computer into a network cable on the desk, for example, or in an actual network port in a lobby that isn't getting monitored. If you actually want to get access to the network, you have to authenticate. So what we've got is a global configuration settings here. Then we can drill down to the port settings in here, and then here we can actually check the status and carry out any troubleshooting. But the idea is once this is set up, as we saw above, we've got a AAA setting where the actual authentication is handed off to a radius server or group of radius servers, although typically they would actually then hand off to Active Directory servers to give you that centralized user authentication. So it is an extremely useful feature, more relevant to access switches, but at least I know that this is something that's supported in those types of switches in this JetStream family. The switch also supports port security, although it is a bit of a basic method of security. The idea is that when you set this up on the ports, you can actually restrict access to the network based on MAC address. So you could, for example, have this learn maybe one MAC address on a port. If anybody else plugs a computer into that port, maybe they plug a hub in and then you have multiple computers, the switch will see different MAC addresses to what it originally learned on that port, and you can actually have it block access to those other computers. You can also get it to set traps as well, so it can send a warning out if, for example, it starts to exceed the number of MACs you originally set up. By default it's set up to 64, but you could just set it up to say, well, I only want it to learn one MAC address for one computer. That way, if I know if anybody's actually changed the computer on the port or plugged in a hub, for example. So it's a pretty basic port security setup, but it is a feature that you could use for securing your network. Now the switch also supports access control lists. And although in this day and age, typically when it comes to security, you'll be using a firewall, which is better than using an actual switch for your actual security rules. But these access lists aren't just for security. You can use them for other things, other features that the switch supports. So what we can do here is to set up an actual access list, and we can also do some binding, but just set up an example one, where we've got a choice where you can set up ones for MAC addressing, ones for IPv4 as well as IPv6, and then we've got a combined option, which is a combination of those two. So let's say I pick one for IP, give this name of, say, test, for example. If we edit that access list, you can start to add in entries, and there's quite a lot that we've got here when it comes to choices in terms of what we can do, but as you can see, we can actually use these for policies as well. So as I say, it's not just specifically you're going to be using these for actual security to restrict access to things. You can use them for your actual traffic mirroring, redirection, rate limiting, QoS remarking as well. But when it comes to the actual binding, the security side of it, you can bind the actual access lists to ports, for example. Pick out what your access list is and tell it you want to apply to a specific port, which usually makes more sense when you're dealing with actual MAC addresses. You want to be able to restrict traffic between certain ports, for instance, or restrict what they can actually get access to based on MAC addresses. But then we've also got a VLAN binding option as well, where we actually apply the restriction to the entire actual VLAN. So it's quite a bit of flexibility. As I say, in this day and age, typically when it comes to the security side, I'd be more inclined to be using access lists on a firewall. But we get quite a lot of choice here, really, which is pretty useful. Now, if you're ever concerned about somebody being able to plug just any computer into the network and getting access and even causing problems, well, that's where IMPB comes into play. It's called IP MAC Port Binding. And we've got an option for IP version 4 and IP version 6. With IPv4, we've got ARP. With IPv6, we've got neighbor detection, but the principle is the same. So the idea is that you want to actually check what are legitimate IP address to MAC address bindings, but also what port that actual computer is on. And the switch can learn this information either through DHCP snooping. So it can actually monitor DHCP traffic to learn the actual IP address to MAC address bindings, for instance. But when you've got computers that have got static IP addresses, then you can put in manual entries. But once it's got all of this information and it knows which computers are on which ports, what their MAC address is, what their IP address is, if somebody were to come along and actually plug in a computer, even if they give it an IP address in the correct actual network range, well, chances are the MAC address doesn't line up with what's in this binding table. And that's where this IPv4 source guard comes into play. Because what you can then do is set this up to actually block access from that computer. So it is a very, very useful feature. Now, go back to this actual page here. We also have an option to actually run an actual scan if we want some information. But then we've also got an option for ARP detection, and then the IPv6 equivalent is neighbor discovery detection. But this is where you've got a computer on the network causing problems by flooding ARP traffic, for example. You can actually rate limit this sort of traffic. So that's useful not just if somebody plugs in a computer and starts trying to cause problems, but also if somebody's actually compromised a computer as well. So as I say, we've got options for both protocols, and from a security perspective, definitely a useful feature to set up. Having a DHCP server on your network is extremely useful because it saves you having to go around every computer and manually configure that IP address. The only trouble is, whether it's by accident or deliberate, if somebody introduces an additional DHCP server into the network, it can cause a lot of problems. Likewise, you might have somebody up to no good on the network who's actually trying to cause problems for your DHCP server. And that's where this DHCP filter option comes into play. So we've got one option for IPv4 and another for IPv6. So what you can do, for example, is to actually tell the switch what are the legitimate DHCP servers. So that way you actually block other DHCP servers on the network. But then we can also set up features like MAC verify, rate limiting, and decline protect to actually protect the actual DHCP server. Now, hacking isn't just about breaking into a computer and stealing information from it. It can also involve denial of service attacks. So that could involve overwhelming an actual computer with traffic or starving it of resources. In any case, if you've got a situation where your service isn't available and you can't resolve it, then you could be forced to actually pay the hacker some money to, well, restore that service. The switch here does actually have some features to help you with those sort of situations of denial of service attacks. By default, they are actually disabled, but this is something you might want to consider and add to your security tool belt. Now, the last tab that we've got on our dashboard is for maintenance. And the first section we've got is System Monitor, and this allows you to monitor the CPU utilization as well as the memory utilization. Now, switches like these, or any switch for that matter, typically doesn't actually have that much actual resources. Certainly doesn't have like high-end CPU behind it. In which case, this is more for basically troubleshooting when you've got certain problems and you want to check, is it a problem? Maybe the actual CPU is getting exhausted, or maybe we're actually running out of memory. Maybe there's an actual software bug or something that's causing memory leaks. In which case, what you do is come to this System Monitor, click on the Monitor button, and then just watch this for a short period of time just to see what's actually going on. And then when you're finished, although you don't see it, you would click on the Stop button to turn it off. So in other words, you wouldn't want to be running these sort of things 24/7. It's much, much better to have a dedicated monitoring actual solution that actually pulls the actual switch for information using SNMP, for example, for that. But in those tight spots where you're after some quick information, it is still useful to have a feature like this. Now, typically whenever users are having problems, it's the network that gets the blame for it. Fortunately, we do have this traffic monitoring option, which gives you a bit of a top-level view of what's going on within the network. So we've got our traffic summary here, and what you can do is find out the amount of traffic that's being received or transmitted on a port. So that could be packets or octets. You can also drill down to get more information on a specific port to get statistics, which can be useful for things like the alignment errors, collision errors, or whether the port's just getting overwhelmed, for example. So this is very useful if you want a top-level view to see if the traffic on the actual network as a whole is just overwhelming the actual systems, or whether there's just a specific computer on a specific actual port that's got the issue. And you do have options where you can auto-refresh this while you're looking at it, or you can just click on the refresh button to get information straight away. Now, there are times when you'll have problems on a network and you want to be able to analyze the actual traffic between, say, two computers. Now, unless one of those computers has something like Wireshark installed, then it's going to be a bit difficult to do that. In which case, we do have this port mirroring option, which allows you to actually replicate the traffic from one or more ports to a specific destination port. You could then plug in a laptop, for instance, into that destination port that has got Wireshark on it, and then you can actually analyze the traffic. So for this switch, we've got one session. You can't create any more. But if you click on the edit option, we'll set what our destination port is. And as you can see, we can't have more than one, but you can have one or more actual source ports. Now, one other useful feature about this is you can also actually set it up to monitor the actual CPU for the switch itself. In other words, you can actually monitor the actual traffic for the switch itself. But one thing to bear in mind about this is it's only really intended for troubleshooting purposes. So this is a sort of like a one-off situation where you would set it up whilst you're troubleshooting, and then when you've actually finished, then you would actually disable the feature. I have come across customers in the past where you've got, say, like a telephony solution, and they want to be able to constantly replicate, say, voice traffic, for instance, from certain ports to a specific computer that's recording traffic. Or maybe there's wiretaps, for instance. We want to be able to forward the traffic from multiple ports over to a wiretap where our actual network's getting monitored there for security purposes. That's not what this sort of session's for. It's purely just for those troubleshooting one-off situations. Now, although we're on the maintenance tab, there is a very useful feature here called S-Flow, which is short for sampled flow. So we're not talking about just basic traffic monitoring to find out the volumes of traffic on your network. We're actually talking about getting a breakdown of the applications that users are connecting to, or at least trying to connect to. So this is extremely useful for understanding what's going on within your network, especially from a security perspective. If you've got, say, a computer that's being compromised, for instance, and somebody's up to no good. Now, it's relatively straightforward to set up. You've actually got to tell the actual agent here what IP address we're going to be sending the traffic from. So typically, it'll be the IP address of its management interface, for example, although we are limited to version 5. You've then got to point it to a collector. In other words, there's going to be a computer that you're using that's got the proper software to actually put together all of this information and give you it back in a readable format. In other words, you'll be able to get like a pie chart that tells you what the top talkers are, for example, or the top types of applications that's in use. So it's extremely useful. And you can then set this up on a per port basis. You can even set the actual sampling times and so on. So it is very, very useful, especially on a switch like this. Ethernet OAM, operation, administration, and maintenance is a pretty useful feature to find on a switch like this, because what it allows you to do is to keep an eye on the actual layer 2 links that you've got. So what this all allows you to do is to actually get alerts, for instance, if a link fails, or even if there's actual errors on the actual links. DLDP, or Device Link Detection Protocol, is extremely useful if you're going to be using fiber. The reason being is that when you set up a redundant network and your switches are connected to each other over fiber, well, normally spanning tree will block one path. The only problem is if you get a wire cut and fiber has 2 wires, you end up in a situation where you've got unidirectional traffic. Spanning tree no longer detects a loop, and here presto, you've now got a bridging loop. So that's where this DLDP feature comes into play, but it has to be configured on both ends of the link for it to work, because the 2 devices exchange information, and if that communication breaks, then the actual switches know something's gone wrong. So yeah, definitely useful for fiber connections. Now, it's always good to see a feature like SNMP being made available on a switch like this, especially when we've got so many configuration options, because although SNMP's been around for like a really long time, and I don't know anybody who still uses it to manage computers or network devices, it's still very popular to monitor them. So we've got quite a few choices here. I mean, we can use version 1 or version 2C, for example, but typically you'd really want to be using version 3, because then you've got user authentication as well as encryption, which makes a lot more sense than these older versions where everything is in clear text. And we've got some built-in views, for example, but you can set up individual ones to restrict certain users or certain computers to certain information, for example. So there's quite a bit of flexibility in here, but you can then use that to centralize information, gather information like CPU utilization, firmware versions, and so on, so that you can audit and trend what's going on within your networks. That's extremely useful. And then we've also got the options for notifications as well as traps, depending on which version of SNMP you're using. And that's always good. You want to be proactive, especially in a network where you've got redundancy. Last thing you want is for, say, like the redundant link that's not doing anything to actually fail. And then after a certain period of time, the actual primary link fails as well, because then, well, everything's just fallen apart. So you want to be proactive. You want to be on top of any part of the actual system that's actually broken and not working, so that you can get it fixed before things get even worse. And then as well as that, we've also got ARM on for traffic monitoring and reporting, alerting. So that's a useful feature, although I must admit it's not something I've used myself. Most of the things I've tended to use these for is to gather the information and trend all that within the actual management device itself. But the feature is there if you want to use it. Logging is extremely important to computers. You want to use it for troubleshooting when things go wrong, but also you want to audit things to see what's actually going on within your network and on computers. So this particular switch, it's offering local as well as remote options. And here on the log table within this log section, we get to see quite a bit of information, because at the moment it's recording pretty much everything. And we're getting to find out who logged in and actually when logins failed, who's actually created ACLs, who's deleted ACLs. So there's quite a lot of good information being collected here, but you can actually filter that out as well. If you then go to local logs here, you can change severities, you can enable or disable the options. So we've got a log buffer, which is for the more immediate sort of information. So it'll basically cycle through this sort of information. Whereas you've also got a file option where you store that information to a file. We've then got the option for remote logs. So we can actually send our logs out to remote servers, and we've got a choice of up to 4. We can set different severity levels as well. And in this day and age, typically what you do is have some central solution that does all of the actual logging collection. It collects all of the syslog information, which is what that UDP port 514 is for. And then that all gets analyzed. One thing to bear in mind though is that it's not offering an option for encryption here. So that means we're using syslog in clear text. That's something to bear in mind. You want to be very, very careful where that information gets sent as a result, because we've just got to go back to this log table here, and you can see we've got IP addressing, user accounts, for example. All that, if it's being sent over to a remote server and it's in plain text, means anybody who could intercept that information in the path has got quite a bit of detailed information, which from a security perspective is really bad. It would have been better if they could have given you an option here to actually encrypt that. So just something to bear in mind. We've then also got the option to back up the logs though, so that's pretty useful, especially if you want to go off and analyze this sort of information, because usually when it comes to syslog information, there can be quite a lot of detailed information in here. You don't necessarily want to just sift through it here. You might want to even send it off to somebody else to actually analyze. But as I say, there's also the option to export the logs as well, which is useful. Now, if you're using RJ45 cabling to connect devices to a switch, then it's useful to be able to diagnose the actual cabling if there's an actual problem. And this actual switch is offering an option of device diagnostics to actually carry out testings on those actual cables. So there's all sorts of things can go wrong with RJ45. Maybe there's a problem with the wiring. Maybe it's running into interference in the path, for example. Maybe you've got distance problems and so on. That's what this is all about, being able to carry out a test if, for example, there's a particular port and you're experiencing problems with it. Now, the last section that we've got in our maintenance tab is for network diagnostics, although I must admit, it's just your typical offering of being able to carry out ping tests. So you can actually run a ping test from this switch to a specific IP address if you're experiencing some connectivity problem. But we can also carry out an actual trace as well if you want to be able to trace the actual path to that destination. So overall, what do I actually think about this switch? I mean, was it even worth buying? Well, when I first started to think about 10 gig connectivity, the only offering really at this sort of like budget level was, well, a 4-port MikroTik switch. Now, since then, I've started to add more devices that are capable of 10 gig, in which case that wouldn't have been enough. So now that I'm actually introducing 10 gig to more devices on the network, this 8 ports is pretty much as I'm going to need, really. I'd say it's kind of like in the Goldilocks area, the sweet spot for me. There's plenty of actual ports to cover what I need now, and that's probably about as far as I'll go. So for that reason alone, and given the price, it was worth it, I'd say. For all the features, well, there's a lot of features on here. I mean, if you're going to go beyond this, you're really into layer 3 switches anyway, enterprise grade switches. And to be honest, I think they've more or less had that time anyway, because firewalls nowadays tend to get used to separate the VLANs from a security perspective anyway. They were very, very useful when they came out to be able to route your traffic between the VLANs instead of having a router on a stick, for example. They would be able to switch the traffic at hardware level very, very quickly, whereas now it just goes through a firewall anyway. A lot of things are tending to get virtualized as well, so usually you're only just going to need a layer 2 switch, but it's nice to have all these extra layer 3 features as well. From a sort of like a small business user perspective, I'd say, yeah, this covers pretty much everything you're going to need. My only concerns, I would say, was that security aspects of things like SSH. I'm really surprised at that limitation that they only offer up to SHA-1 because it's been deprecated for a reasonable amount of time, I'd say. And at the moment, I'm not seeing a way to actually support SHA-2. But given the who this is aimed at and that the expectation is it would all be managed through the actual GUI, that's probably not that big of a concern. And also, there's that looking ahead a bit into software-defined networking anyway. I mean, if that doesn't use SSH, well, do you really need it? It's great for automation, or at least it was, but software-defined networking could be something completely different. Not something I'm looking at the moment myself, because I would need more switches to justify using it, but it's there. I mean, in this day and age, pretty much everything's running in hypervisors as well anyway. So typically, I think the long term is going to be switches that are just pretty much just dumb layer 2 switches anyway. Everything running within the actual hypervisors. So you don't need a great deal out of a switch. So yeah, I'd say for me, this pretty much just hits the sweet spot, just what I'm looking for. Now, if you find this video to be useful, then do consider subscribing to the channel, as that would really mean a lot to me. But it's also a good indicator to let me know how videos like this are helpful to people such as yourself that are watching. In which case, thank you. On the other hand, if you're not ready for that level of commitment, then I'd really appreciate it if you could press the like button, because that way that'll help to get the video out to other people that might find it useful as well.